better. All right. Anybody come up? Let me ask. Anybody come up with an answer for number 5 yet? Anybody got that? Let me ask you this. Under the radical symbol, the radicands, are these the same? The 12 and the 4, are they the same number? No. So you have to change them to be the same. And the bigger one is the one you want to focus on, that 48. And that breaks out to what? How does that factor out? You're trying to think. All right, so let's go back to our strategy. All right. Okay. We'll strategize this. What is one thing I suggested that you do to begin with? List your what? Yeah, list your perfect squares. Because when you're factoring any of these, you're simplifying and adding and subtracting radicals, rational expressions using radicals. You want to list out your perfect squares, okay? So I'm just quickly going to jot down my perfect squares. And these should be pretty automatic for you. All the way up to 12 times 12, okay? You guys do know how to get your perfect squares. Just list 1 through 12 and multiply it to itself. So I'm looking at 48, and I'm noticing that 4, that perfect square of 4, will divide evenly into 48 how many times? 12. 4 goes into 48 12 times. Now, if I'm struggling with any of this, I pull up my phone or my calculator and I look at 48 and I'm like, okay, I'm going to try, well, 1 goes into 48, but I need 4 goes into 48 12 times. Then I got to break down 12. 16. I keep going through the list. And I take 48 on my calculator. I go 48 divided by 16. There it is. It's 3. So when I'm breaking apart a radical expression and I want to simplify it, I start going through my list, working my way up. I'm trying to find the biggest perfect square. So 16 is actually, 48 is actually 16 times 3. And guess what? 16 is a perfect square. So it's going to come out of the radical as 4, right? The square root of 16 is 4. So I've got my 7, change color, 7 radical 12 plus 10 times 4. That's the 4 that comes out, radical 3. Well, now they still don't look alike. So now let me focus on the 12. Let's break down that 12. What times what will give me 12? 4 times 3. And 4 is on my perfect square list. So I'm going to break down 12 as 4 times 3. Aha. The 4 is a perfect square. It's going to, what's the square root of 4? 2. So 2 is going to come out and get multiplied to 7. 7 times 2, radical 3. Aha, I'm getting somewhere. Plus 10 times 4, radical 3. Now my radicands look the same. Radical 3, radical 3. And I just do the multiplication out front of them to the left. 14 radical 3 plus 40 radical 3 gives me a grand total of 54 radical 3's. Any questions on that one? You got it written down, my friends? You sure? Written down all these, anything I put on this board needs to be written down on your paper. So this year has kind of thrown me off in some of the ways I taught. And now I'm like, oh yeah, because I had my kids every day. Anything that I felt that was important enough to write down, and you don't already have it written down, you need to be writing it down on your paper. Okay? It's definitely important. Okay. So 54 radical 3 is the answer when you add those two. All right? Let's go to the next one. These are cube roots on number 6, and they're not all the same. So you've got to simplify the second and third one so that you can put all those together. Okay? And then we're going to move on. We're going to move on to multiplying. Okay? Let's go to number 6. Strategy I suggest is listing out your perfect squares. The two I'm really going to focus on are the 16. I'm going to work that one first. How would you tear apart 16? Say it again. That's a perfect square. Yes. If it's not working, just toss it because I've got plenty. Yeah, 16 is a perfect square. So, okay, that's easy. So I'm going to rewrite the first one. Cubic root of 2. And now I've got minus 2 times 4. Whoa, wait a minute. We're doing cubic roots. Pay attention. All right, let me back that up. Cubic root. Two times 2, 4 times 4 is 16. 8, 2 times 2 times 2 is 8. So, oh, okay. Now we're looking for perfect cubes. We haven't listed our perfect cubes. You guys know your perfect cubes? 1 times 1 times 1. Let's list those because we're doing cubic roots. 2 times 2 times 2 is what? 8 is another one. 3 times 3 times 3. 27. 4 times 4 times 4. 64. Good. 5 times. What? Like when he does that a lot. And when he does that, I'm wondering what relationship that has to teaching a foreign language. He's very like animated. Okay, so 5 times 5 times 5, 125. These are our perfect cubes. Now, when I break apart, I got to pay attention. I didn't pay attention at first. We're doing cubic roots. So I'm trying to find something on the list, 1, 8, 27, 64, 125, etc., that I can break down the cubic root of 16. And I'm starting to see that 8 times 2 gives me 16. So I can break this one apart to the cubic root of 8 times 2. And since 8 is 3 times 3 times 3, it's a triple, it gets to come out. When we're doing cubic roots,
that's not 2 times 3 times 3.
2 times 2 times 2. I was thinking threes and root threes. 2 times 2 times 2. It's a triple, so it gets to come out as a single. See, when this indice, this is called your indice right here, this little number, it tells you you're looking for sets of triples. If it's just a radical symbol, like this, it's assumed to be what number in that little area? A 2. So you're looking for pairs. See the difference? But it follows the same logic. Okay, so since we have triple 2s, a 2 gets to come out. All right, so let me shrink this back down. Let me start this over. I've got negative, come on, -3 cubic root of 2 minus, we're going to pull out a 2 and multiply it to that other 2 out front, which will give you 4. Hello? Yes? Yes? Uh-huh. What are you talking about? Nobody heard that, right? Nobody in here. Well, they don't listen to me, so they might not be listening to you. No, I'm just kidding. It's me. And we were wondering on our end, what does Gregory Hines and his tap dancing have to, how does that relate to teaching a language? It's art, it's dance. I'm selling your class to my students right now. It's math too. Yes. The force, it's physics. The force of which his feet hit the ground. Yes, of course. That, yes, I love that movie. I was a big tap dancer back in the day. Oh, yes. I can shuffle off the buffalo like nobody's business. You want me to do some drawbacks and everything else? It's okay. I might have to bring my tap shoes in. Yes. All right. It's actually really fun, and it's quite challenging. You have to balance yourself. And back in the day, we thought we were the Rockettes. So we always, well, yeah, they were wannabes. So we tap dance in 1.5 to 2 inch heels. Yes. So, yeah, so to do some of those moves, your weight is shifted on the ball of your foot, and you're doing, but anyways, yes. I might have to bring back the old, the old Janet Jackson days. Yes. Dun, dun, dun. Okay. Yeah, that's us down here. All right. We'll catch you later. Yeah, he was wondering who was hearing him do his dance moves. And he's always wanted to learn to tap dance. And as you can tell, I did tap, jazz, ballet, and gymnastics. I know, don't let the figure fool you. But yes, that's what I used to do. And then I played softball, ran cross country, swam. I did whatever they let me do back in the day. I just picked up and did whatever. All right, so we're back here. So a 2 gets to come out and get multiplied to this 2. So that becomes 2 times 2 is 4. There's 4. I'm quite over here. I can walk around, talk to you guys. So this is 4, because we brought a 2 out and we multiplied it to that other 2. So I'm going to get rid of that. That's 4. And under the radical, we keep the other 2 because it didn't have any triple to go with it. Aha, now we're getting somewhere. So this last one is actually, I think that's 27 times 2, isn't it? It's a triple. It's 54 breaks out to be 27 times 2. Now he makes me want to teach a foreign language because that sounds like so much more fun than this, right? I guess I could just figure it out. I don't know. I could learn to babble and start teaching. That would not be hard. It would have to be like introductory because that's all I would know. All right, so then we do 57. So I'm thinking 27 times 2. So I take my calculator and I go 54 divided by 27 is 2. So I'm going to break this down as the cubic root of 27 times 2 because I know 27 is a perfect cube. 3 times 3 times 3. So guess what? That 3 is going to come on out. And the radical 2 stays under the radicand. The 2 stays under the radicand. Now they're all like terms. They all have 2 under the radical symbol. The radicand is 2. And I can just add and subtract their coefficients, which is this number right here. -3, take away 4 is -7, add another 3. This -3 and +3 cancel, actually. So we're left with -4 cubic roots of 2. We're not going to do the other 2. Actually, I'll have you guys do them. Bring them to class Thursday and we'll go over the answers. But I want to move on a little bit. Are you starting to see how this works? Think you can do a couple on your own? I got to. Okay. Let me back up just for a second because I'm seeing some people go, what is she talking about? Okay. The only 2 you guys are going to have to know. Oh, hang on. Let me get some paper. Let me get some virtual paper here. What color do you want today? What color? We're going purple. All right. So the deal is you have to know how to simplify a square root and a cubic root. You have to know how to simplify those. In the ones I just put up, you're lucky. The first one's a perfect square. It's 10 times 10, right? So those, you've been doing those a long time, haven't you? Figuring out how to work. That doesn't help, does it? How to work perfect squares. This one, let's see if we can do it. Aha, that's what I need. Okay, so square root of 100 is 10, right? That's how you simplify that. You guys with me? That make sense? Now the cubic root of 8 is what? 2 times 2 times 2. So we just simplified these 2. But what they've done is they've made it a little more challenging. They put a number under the radical symbol that has to be factored first. And in the square root situation, they say, oh, square root of 50. That's not a perfect square. It's not on the list. But it does factor to 25 times 2, right? 25 is a perfect square. We're looking for things that we could pair up because we're dealing with square root pairs. And so the 5s are paired, so one of them comes out side of the radical symbol. The 2 has to stay under. So this is the simplified 5 radical 2 is the square root of 50 simplified. They're not asked, they don't want you to put it in a calculator. They want that. Now let's do a cubic root of I think 96 is one that I could do. And so I'm starting to think cubic roots. So I'm like, okay, 1, 8, 27, 64. And I'm like, I think 8 goes into that. So I go 8 into 96, 1, 8, 12. So I break this down as 8 times 12, and I know 8's a perfect cube. So that 2 comes out front. Now 12, does that break down to 2 times 6? I'm looking for perfect, no. So it's 2 radical 12, 2 cubed roots of 12. Okay, that's how you break these apart. All right, now the square root stuff, they are going to have you, they're going to throw in variables with exponents. So let's say you had to simplify the square root of 50, which we just did, x to the 4th, y to the 3rd. Let's say you had to simplify that. So the first thing you simplify is the 50. 25 times 2, the 5 comes out. the 2 stays under. Then you expand your variables. Right? And you look for pairs. Here's a pair, so one of them gets to come out. Here's another pair, so another one gets to come out. Here's a pair of y, so a y gets to come out. But the other one is stuck. He's stuck under the radical with the 2. So now I have 5 times x times y, radical 2y. Now you wouldn't leave it written like that. You would take those x's and rewrite them as x squared. So this would show up as 5x squared y, radical 2. The same thing's true if they were asking for a cubic root of y to the 6th. I would expand the y to the 6th. 2, 3, 4, 5, 6. There's a shortcut, but I'll teach you that in a minute. So I've got my 6 y's written out, and I'm looking for triples. There's one comes out. There's another triple, that one comes out. Oh, there's nothing under the radical. So when we actually simplify that, it's y squared. That is the cube root of y to the 6th is y squared. There's nothing left under the radical because we accounted for 2 sets of triples. Now the shortcut is you do 6 divided by 3, and that tells you your answer. You do 6 divided by 3 to get the 2. You do 4 divided by 2 to get the 2 out here. Anyways, I would just expand it out and look for pairs or triples. Okay, so let's move on. You guys are not doing surface area and volume. Let's go back to our unit here. Okay, I need to go back here. Okay, so work those other ones, bring it in tomorrow. We'll go over the answers. I can't get to where I want to be. Instruction. Okay. All right. What the heck? All right. I should be able to click. Oh, I know what happened. Okay. All right. So add and subtract radicals. Done. You need to get the radicand to be the same, like x's. You can add and subtract x's, same variable, same exponent. Did you guys get a copy of this worksheet? Did she physically give you a copy? Let me show you what it looks like. This worksheet is posted. It's extra practice, and I have the answer key. So I want you guys to have it so we can go over it for any kind of clarification. It looks like this. This is what it looks like. See if you have this. This is what it looks like. See if you have it. Oh, you're good. It's also virtually there, but I have printed a bunch of copies to see if you guys. Did you get one?
I got one.
If you don't have it, I have extra copies that say add and subtract radicals.
This is multiple.
Okay, that one is another one. Do you need a copy?
I have one.
Here it is. You have what?
I have one.
You were absent today. That came out. Did you find it?
Yeah.
Okay. So what I'm going to do, yes. Okay. I'm going to go over the answers, some of the answers with you. I'm going to do the odds. I'm just going to tell you the answers. Then you guys can practice the evens and we can discuss. But I want to move on to multiplying. Okay? So this will be like a, so let me give you the answers to the odds. All right? So the first one, radical 20 plus radical 5 The answer is D, 3 radical 5. The answer is D for number 1. If you did it, check it. If you didn't, circle the correct answer, go back and see if you can work it and get that. That's the correct answer. A lot of times math is like the practice, but if you already have the answer, you can work it on your own and make sure you're getting it. That's how you check your progress. Number 3, the answer is A. So the cubic root of 162 plus the cubic root of 48 is 5 cubic roots of 6. Okay. Number 5 is 6 square root of 2. So let me scroll this up a little bit. That you don't have an answer, but it's a 6 square roots of 2. Number 5. 6 square roots of 2. Number 7. I wonder why they did that. There's no, they simplified them, but they didn't, well, let's see what they ended up with. They ended up with -9 square root of 3 minus 5 square roots of 2 minus 9 square roots of 5. And that was the end result. They couldn't put any of those together. But that was the final result for number 7. -9 radical 3 minus 5 radical 2 minus 9 radical 5. That makes sense? Oh, it looks like they combined some of them because there were 4 to begin with, so they definitely combined. All right, and number 9, they ended up with, hold on. Where's number 9? Hey, what happened? Hold on, I lost my spot. Was number 9 cut off for you guys, or? Okay, well, we'll just go over number 9. Number 9 is the cubic root of 3. I'll just write it here. Cubic root of 3 minus 4 cubic roots of 6. And that's where they had to stop. They couldn't put those together because there's a 3 and a 6 here. So they can't, that's it. You can't combine those at the end. All right, so I have the answers to the evens. You guys need to try the evens. But before we do that, let's move on to multiplying, because multiplying is pretty easy. Multiply. All right, it's pretty straightforward. So take out your multiply radicals worksheet. These. If you don't have it, let me know. If you don't have multiply, let me know. Okay. So we're looking at the notes. Let's go through. There's 3 short videos we can. Oh, no, hang on. I have to switch gears. We're going to go over these videos. So hang tight 1 second. I got to quit here. Stop. Okay. And then I'm going to go screen. Okay. Share. 1. Sorry about that. Yes. Class notes. Multiply radicals. There we go. This way I can play the sound. It's thinking. Come on, computer. How many of you get so annoyed by this? Technology. All right.
Welcome to Algebra 1.
Yes.
Let's have a discussion on how to multiply radicals.
All right.
This still comes from the SOL 8.3c. The student will simplify numerical expressions containing square or cube roots. If you remember, the earlier part of this lesson dealt with adding and subtracting expressions. Now we're going to multiply the expressions. So in order to multiply radical expressions, the indices have to be the same.
The indices.
Which
is that little number, the square, or the cube?
are identical.
But the number underneath doesn't.
You simply multiply the term in front of the radical and multiply the terms that are the radicands. As a reminder, you cannot add or subtract the radicands. Be sure that all answers are simplified completely. So basically what we have here is we're going to be given some radicals, either squares or cubes. You're going to multiply the numbers that are in front of the radical signs, and then you'll multiply the numbers that are under the radical signs. And this is all assuming that the indexes or indices are identical.
So you couldn't do this with a square root of something and a cube root of something. It'd have to both be square roots to multiply.
And that's when you start with your prompt factorization and continue from there. Let's start jumping into some examples and see how this all plays out. So for this first example, we're going to take the square root of 24. We're going to multiply by the square root of 18.
They're both square roots,
Now,
so yeah.
It is possible. I don't want to say it's not. But you could simplify the square root of 24 and then simplify the square root of 18 and then multiply. But chances are, if you take an approach like that, you will then have to simplify it again. So instead of maybe just simplifying once, you would probably have to simplify 3 times. So I'm a fan of let's just multiply the numbers, even though it makes a larger number.
Just multiply the two numbers.
Because you have a calculator. You're not doing this mentally, right? You're not just trying to do it all in your head.
Use your calculator.
Let's just multiply the numbers. Now, we're allowed to do that here because they both have an index of 2, right? And so we can multiply these radicands together. 24 times 18 is 432. Now, again, granted, that's a much larger number to prompt factorize and break down, but we only have to do it once. As opposed to, hey, let's break down 24, let's break down 18, let's multiply, let's break it down again.
Yeah.
Okay?
Don't break it down till the end.
Again, it doesn't matter which way you do it, but I'm going to stick with, hey, let's just simplify once if we can pull it off. So, lowest number.
I don't know about you guys, but yeah, you could have simplified the square root of 24, square root of 18, brought the, perfect square out, and then gone that route. But he's just multiplying them straight across and then going to break down that 432.
Other than one that goes into 432 would be 2. And it goes into there 216 times. And again, you can pull all of this off with your calculator. 2 goes in 216, right? Even number. 108 times. 2 goes into 108. 54 times. 2 goes into 54. 27 times. 3
times 9.
3, 3, 1. All right, and remember, we're just looking for pairs because it's a square root. So
now he's going to go down his prime factorization. Doesn't look like a tree. It kind of looks like a ladder, the way he does it. But he's going to go down here and he's going to start looping around his pairs of factors. He's going to loop here, so a 2 is going to come out. He's going to loop here, another 2 is going to come out. And he's going to loop here, and a 3 is going to come out, and he's going to be left with a 3 under the radical. Just so you...
A pair of 2's here, that will leave us a single 2. Pair of 2's here, that will leave us a single 2. And a pair of 3's here, that will leave us a single 3. So I have 2 times 2 times 3, which is 12. And then left under the radical sign is a 3. So the square root of 24 times the square root of 18 is 12 times the square root of 3.
Yeah.
Answer.
That's the final answer when you multiply those two
And then
radicals.
we've been given 2 times the square root of 30 times 3 times the square root of 40. And we're asked to multiply this. Again, you could break down 30, you could break down 40, you probably have to do it again, but let's just go ahead and multiply.
So they're both square roots, so you can multiply them. You multiply their coefficients, and then you multiply the radicands. So he's going to do 2 times 3 is 6. 30 times 40 is 1,200. So he's going to get 1,200 under that square root symbol. I hope.
We're allowed to do so because the radicands, the indexes are exactly the same.
Square roots, that's the index,
So
the 2
numbers
that's
on the
invisible.
outside would give me a 6. Numbers on the inside would give me 1,200. All right. So let's
Then he's going to break down
this
that 1,200.
1,200. That's the next step.
It's 100 times 12.
And that's probably the hardest step. If you think about it.
Think about perfect squares. It's 100 times 12.
Any of this.
He's going to do all this
You have the calculator,
over
but the
here.
most time-consuming part is oftentimes breaking this number down.
And that works. If you're comfortable,
Okay.
you just keep
You
breaking
don't
it
wanna,
down like that, that's
you know,
fine.
Accidentally do it wrong, because if you accidentally do it wrong, it's going to throw everything off. And math is that subject. Math is that subject of perfection. So you have to strive for perfection here. All right. So I'm again looking for pairs. I got a pair of 2's here, and another pair of 2's here, and I got a pair of 5's. Great. The 2 times 2 times 5 is 20. So keep in mind that you already have the 6. You're bringing out 20, and you're left with 3. So the only thing I have left to do here is just multiply the 6 and 20. You can do that all in one step without writing it out like I did, but that's sort of showing proof of understanding. So 6 times 20 is 120 times radical 3. Look at a couple more examples.
Okay. Any questions on that? Multiplying's pretty easy. It's just if you can get down the simplifying part, breaking it apart at the end to give the final simplified answer. So flip over to the next sheet, the cubic root of 50 times the cubic root of 20. And since they're both cubic roots, you can multiply them. Just go ahead and multiply that and rewrite it as the cubic root of something. And I'll go to that video. Okay.
Let's do some cube roots, huh? Now we're allowed to multiply these again.
So when he multiplies those, what's he going to get? The cube root of what? 1,000.
Because they both have an index of 3. And so let's go ahead and do it. Let's go 50 times 20. And so that will give me the cube root of 1,000.
Cube root of 1,000.
What you should do if you don't totally recognize the number, you just want to be sure, one smart thing to do is to see if that's actually a perfect cube. And if you type that in your calculator, you're going to prove to yourself that, oh, there is such thing as a cube root of 1,000. And it's 10.
Yeah, so if you put cube root, so
10
it's 10 times 10 times
10
10.
is 1,000. So 10 is the final answer. That saved us from having to take this 1,000
And break it down.
break it down, right? I don't want to break that down and keep going. Just taking a few seconds and testing it out
Yeah,
in your
test it
calculator.
in your
may
calculator.
save
Is it a
yourself some
perfect cube
time.
already?
Cube root of
And actually, 1,000
1,000
is 10 times 10 times 10.
final answer. That is not something you would have pulled off very well if you tried to break these down separately. Hopefully I'm making my case for.
Yeah, so he didn't break them down in the beginning, and look how easy that was.
All right, let's take a look at our last example before we head to the now you try section. Let's take a negative cube root of 90 times 4 times the cube root of negative 150. Now,
All right, so see what you get. They're both cube roots, so they can be multiplied. Use your calculator and see what how you're gonna rewrite that first step. Okay, what would you write? You're doing some multiplying already. We can get it right. You ready? So, how many of you multiplied 90 times negative 150? Everybody should have done that because it's cube roots of both, so you can do that. So 90 times negative 150 goes under the radical, the cube root symbol. But don't forget that there's an invisible negative 1 here, and it gets multiplied to the 4, the coefficients. Okay? So don't forget that
we
part.
have the same index. It's okay to have a negative 150. We discussed that before. Odd indices or odd indexes can have a negative radicand. It's
A
the
cube
even
root, a
ones
fifth
that
root of
do not.
something,
So we're
under
okay
the radical
there.
can be a negative number. The even
That's why
ones
it's not
has to be
multiplied,
positive.
what we see here.
Till you get into imaginary numbers.
Negative
That's how
4 times 4 is negative 4. And then we have the cube root of 90 times negative 150 will give me a negative 13,500.
Oh.
Ooh, big number there. But what's the big deal? We got to calculate. Right?
Yeah.
So 13,500, even number. Let's cut it in half. That'll give me 6750. Even number. Let's cut it in half. 3375. Not an even number, so I have to think about it. I'm going to think about 3. 3 does go into there. 1,125 times. Not an even number, so let's try 3. 3 does go into there 375
So he's
times.
breaking it down.
And
Remember, we're looking for cube roots.
375 times. 125 times.
125 is a perfect cube.
And we have 5, 25, 5, 5, 5, 1.
So now he's going to look for triples.
Triplets. Don't have a triple set of 2s. Almost did
Triple
circle it.
3s and
We
triple
have a triple
5s.
set of
They're going to
3s
come out.
and a triple set of 5s. So they're going to get to leave the radical sign. So we have a negative 4 already out there. I'm going to carry with it a 15, but because it was a negative 13,500, I'm going to bring out a negative 15. Okay, I'm going to take that negative out because remember we've discussed this before. That is really a negative 1, and the cube root of negative 1 is negative 1. So I'm going to bring it outside. So now it's a negative 15 times the cube root of, looks like I have a 4 left over.
2 times
So
2. The
negative
4
4
came from the
times
2 times
negative
2 under the radical.
positive 60 times the cube root of 4. And that's the final answer. I do want to remind you before we get to the now you try section. If you haven't thought about it already, let me remind you. You can check this work using your calculator. You can see that I have typed in the last problem that we just did.
He
I
typed it
into
in
the
here.
calculator,
6
enter
radical
the decimal 9,
cube root of 4.
2, etc. Right? And then I typed my answer, and I got the same decimal. That's a really good feeling when those decimals match up. Those decimals.
So you guys have a Desmos calculator. So if you're taking a standardized test and they give you this problem and they say simplify this, multiply these rational expressions, and simplify. So you take the original problem and you type it into your Desmos, and it gives you an answer. Then you can just simply test the 4 choices they give you, unless it's a technology enhanced where you have to type in your answer. But your answer should match the original problem. So that's how you check it. Okay. These calculators, one that looks like this, you guys will be provided before we test, and we'll go over a few things with them. But I recommend the Desmos.
Even if they do match up, it's only provided that you actually did the problem right. And I know that's hard to grasp, but it is possible to only partially simplify the problem and the decimals still match up. So assuming that you have completely simplified the problem, then this would definitely guarantee that you got the problem right or wrong, depending on if the decimals have matched up. All right, so don't forget about that little technique in the calculator.
All right. So now we are on the next video, which is the now you try. Okay. So the now you tries. So I want you guys to work number 1. We'll go over the answer. Then we'll work number 2. We'll go over the answer. We'll do all these. We'll go over the answers. And while you're doing that, okay, while you're starting to work those, use your calculator. I'm going to look at something for you guys real quick. Make sure I'm not rushing you through anything. Go back. Modules. All right, add and subtract, multiply, practice problems. Because I keep forgetting I have you guys 4 days. I'm trying to rush through things in 2 days. Check for understanding. Good. We'll do that on Thursday. We've got these 2 quizzes here for Thursday last week. Did they give you copies of those? But they didn't give you the answers, right? Just copies. Okay, good. Because I made more copies, but we'll go over those too. And then the Delta Math, I think I changed the due date on that. Let me double check it. Delta Math. Hold on. Wait a minute. Well, I'll check it in a minute. Can't check it on here. Okay. So I'll make sure the due date, I think I changed the due date for that to this Friday, the Delta Math, which is the 5th. And then the quiz that was in the quizzes app, this one, this got changed. The due date on this one is, I know I changed it. Hold on. Yeah, this is going to be due Friday as well. I'm going to give you all paper copies. I swore I changed that. Okay, let me do that one on Friday. Yes, that one has been changed. Okay. Let me make sure the other one has been changed. let's edit this. This one I did change. The delta math I changed. And I'm pretty sure I changed it in the application as well. Okay. All right. Tuesday. No. Now you try. How many of you don't have not finished the number one? Then now you try. How many of you not finished number one? All right. So Sean, we'll start with you. What'd you get for number one? And we'll work our way around. On the now you try.
All right, let's have you try these four problems.
What'd you get on number one? Did you finish that one yet?
Not yet.
Okay. Zach, do you have an answer for number one? What'd you get? 6. Radical 3. C. Well, can you multiply those? How do you know you can multiply those two radicals? What's this? What are you looking for? Let's make sure we understand it. How do we know we can multiply? There's a big multiplication symbol there, but how do you even know you can really do that? What did he talk about? You guys remember?
Oh, I did the
It's multiplication. So the only reason you can multiply these two is because the indice, which is that radical symbol, that invisible 2, they're both the same. If they weren't the same, you wouldn't multiply. Make sense? Okay, so this is square root. This is a square root. So take 12 times 48. What'd you get, Hunter? Uh-huh.
The whole problem.
Well, what did you get 12 times 48? Did you write that down?
I don't know. The whole problem.
But you did it on your calculator?
Yeah.
But you didn't write it down? Then you have to tear it apart.
Problems. Once you have finished these four, you can
What'd you get for your answer?
24.
Just plain old 24. No radical symbol. Okay, let's
play
see.
again. So at this point, please press pause.
Let's see.
All right, let's start off here with number one. 12 times 48 is going to give me the square root of 576.
That's what I was hoping you wrote down on your paper.
Oh, yeah. I have that.
Can you hear me when I'm speaking? Yes. Okay, perfect. That's what you need to have written down because you just multiplied the two numbers.
Now that number looks a little familiar to me. I'm going to take a few seconds, type it into the calculator.
So he's testing it
Yes,
to see if it's a perfect square.
It does turn out that this was a perfect square.
There you go.
Follow that,
Done.
and also got a 24. 24 times 24 is 576.
So can we multiply them? We check the indice. It's both a square. So yes, we multiply them. We put the product under the radical. Check. We look at it and we say, well, let me just test in my Desmos to make sure that that may be a perfect square already. Sure enough, it was a perfect square. Anybody else get 24? Good, good. Yeah, always check it first before you do all that other work. Throw it in your calculator and see what you get. Okay. All right.
Answer.
Number two.
Number two, we have
Anybody want to share an answer on number 2, or do you need a couple minutes? I'll give you a couple minutes to work number 2, and then I'll take any volunteers to share. Also, if I put, while you're working, if I put a quizzes up and it expires, like the date goes by, and you try to log in, it sends me an email that so-and-so tried to log in at 4:42 in the morning to the quiz. Yeah, I saw that this morning. I was like, oh, that's not good that at 4:42 you's up trying to work the quiz. Should be sleeping. But I said that I know that I'm doing live stream, but for some reason, I think some people aren't getting the memo that of what's going on. So if you have friends that are in this class and they're like, I don't know I can't get to that. I don't know how to say, look, check your email. She sent a copy out. All you got to do is do it and send your answers back. But I'm giving you guys a paper copy today of that quiz in case, because I looked at the results and I think we need to do a redo from last week.
So do we have to do the quizzes online and then the two?
No, because I can't re-release it. I gotta have to set up a whole, it's a pain. So I just made paper copies and I sent a virtual copy into your inbox on campus.
Oh, okay.
So those that are physically here are going to get a paper copy, but it's also in the email. You do?
I've got both mine done too.
Yeah, mine
They're right here.
also.
Both? There's only one.
There was two. There was a multiplying and adding and subtracting.
Yes, I have those as well, but I'm talking about the one that was due.
That was 2 questions. That was
Yeah.
the question one.
It was a different one. Aha.
Yeah,
Some
the-
people
I
didn't
had
get to that one.
That was the multiplication one.
Yeah, it was another multiplication one, yes. Now, she had paper copies of the other 2, but that one was through quiz. Like I gave you the link, the code, and you had to log in. Yeah. All right. Anybody got an answer for number 2? Anybody want to share? Anybody get -6? Radical something? Let's see. Don't be shy.
Numbers on the inside. They both have the same
You have
index.
outside numbers and inside
Multiply
numbers.
here. This will give me a -6 times the square root of 320.
Are we good so far?
Off to the side. I'm going to start breaking down to 320. 2 goes into
Probably tested it in the calculator. It's not a perfect
160
square.
2 goes into 160 80 times. 2 goes into 80 40 times. 2 goes into 40 20 times. 2 goes into 20 10 times. 2 goes into 10 5 times.
And we're looking for pairs.
What? We're looking for pairs.
There's a pair.
Two.
Come out. Another pair.
of twos.
Come out.
And another pair of 2s.
Out.
So, I already have the -6. I'm bringing out with it an 8, right? 2.
Okay. He said he's bringing out an 8. Where does the 8 come from? When he said
2 times 2.
2 times 2 times 2. So all these pairs came out as singles. And when they came out to the left of the radical symbol, they get multiplied together. 2 times 2 times 2. So now he's going to take that 8 and multiply it to that -6. So out to the left of the radical symbol is going to be -48.
2 times 2 times 2 is 8. And I'm left with the square root of 5. This gives me a final answer of -48 times the square root of 5.
Anybody get that one? Good, good. It's starting to sink in a little bit. Okay, that is the final answer for that one. Let's see what we got on the cube roots. So we did a couple cube roots for you.
Number 3, so these are cube roots here. I'm gonna take 147, multiply it by 21.
Question, can you multiply those two? Because the indice, which is that little number, they don't put it here unless it's something higher than 2. It means, hey, what number multiplied to itself 3 times will give me that under the radical? So these are the same, you can multiply.
And I'm gonna get the cube root up.
Cube root of what? When you multiply those two numbers, what do you get?
3,087.
3087.
Of 3,087.
There you go. Use the
Off to
calculator.
side, I'm gonna start breaking down 3,087.
Is 3087 an odd or even number?
Odd.
It's odd. So you can't divide it by 2. Might be able to divide it by 3.
It's not even, so let's try 3. 3 goes into there 1,029 times.
That's also odd.
3 goes into there 343 times.
That's odd.
And then 7
Woo.
goes into there 49. Obviously 7, 7, 7, 1.
Oh,
Looking for triplets, so only have a triple set of 7s.
343 is a one of our perfect cube, or one of our cubes. 7 times 7 times 7 gives you 343. So there's the triplet. That's going to come out front. And what's going to be left? If he brings a 7 out, what's left under the radical?
10. No. 9.
9. The 3 times 3 is going to stay under the radical. The 7 is a triple, so it comes out. Yes, 9 is correct.
So my 7's going to come out, and I'm left with the cube root of 9.
There you go.
Times 3 there. Final answer.
Oh, I love it when they're nice and easy.
And then finally, number 4, again, what are we learning here? We're learning that
Can you multiply those two rational expressions? You should be saying yes, because you look first at the indice, a 3 and a 3. Yep. And so what are you going to multiply first?
4 and 7.
4 and 7. Yep. So what's going to be outside of your radical symbol?
28.
28. Cubic root of what? What's under the radical symbol? Negative 3,000. Let's test our theory
we
so
can
far.
multiply numbers on the outside, we can multiply numbers on the inside, as long as they have the same index. This does. So 4 times 7 is going to give me a 28. Then I have the cube root of negative 3,000. All right, so let's go off to the side.
Do you guys remember that 1,000 is a perfect cube? 10 times 10 times 10. Now, what he was talking about earlier is when you have the cubic root of a number, the number under that radical symbol can be negative. But because we're trying to simplify this, when he breaks this down, that negative is going to come out here, and whatever you have out here, it's going to be multiplied to it. He's not going to leave it under there. He's going to totally simplifying it is bringing out the negative. So he'll talk about that a little
Let's
bit.
break this 3,000 down. 2 goes into 3,000, 1,500 times. 2 goes into there 750 times. 2 goes into 750, 375 times. 3 goes into 375 times 125. 5. Looking for triplets. I got a triple set of 2s.
Triple set of 5s.
Set of 5s. All right, so I already had a 28. I'm going to bring out a -10, right? B root of -1 is -1, so I'm down, that's going to come out with the 2 and the 5. And I'm left with the cube root of.
So he made it negative because he wanted to bring out that negative.
Negative 280 times the cube root of 3. Final result. All right, so in summary, just a few final thoughts here.
Okay,
The indices or indexes must be of equal value.
They must be the same.
To multiply. And if they are, then you're just going to multiply the terms in front and multiply the terms inside, or the radicands. And finally, you have to simplify. Again, that could be the hardest part for many students, is the simplifying part. But rest assured, you will more than likely have a calculator wherever you're at, taking this, and you should be perfectly.
so the calculator helps because if you know how to factor, you just keep dividing, you know, and then you look for triples or you look for doubles or pairs. So do you have this worksheet that says multiplying radicals? This one. I'm just checking. If you don't, I have made some more copies. It's in your module visually, but I think I had it printed for you guys to have last week. Multiplying radicals. Look for the one that says multiplying radicals. Did you write this one already?
This one?
There's multiplying radicals at the top. I'm going to go over the answers to the odds and let you guys look at even. Tomorrow is a virtual day. So what I will do is tomorrow, I'll pick a time later today that I will post the answers. You need to do the evens, but I'll post the answers for the evens, like with the work. Okay, but we'll go over, does anyone not have this? Check it out. We're going to go over the odds really quick before we leave. And those tests that the quizzes we were talking about, they look like this, but they are not the one that was due. They had one, it said quiz. So she probably gave you this one, it said quiz, adding and subtracting radical expressions. And she probably gave you the one that said, another one, multiplying radical expressions, right? These two were given. But the actual quiz that was due in quizzes was something else. Okay, and I made copies of it, so I'll get it to you Thursday. But I sent it out in the email. Okay. All right, let's go over the odds for multiplying radicals. So let me get off this here. And that'll be it for today. We've covered a lot of stuff. So, and Addison, I know you wanted to, so all you got to do is redo it and resubmit, because I don't think I put a limit on the number of submits. Do you feel better about simplifying the radicals and stuff? Okay. If you have any other questions, just see me at the end. What am I doing? I'm still in the meet. Let me stop presenting here. I want to present from here. Sorry, I'm trying to figure this out real quick. Share screen, because I want to go over the odds. Okay. So, multiplying radicals. All right. Okay. So number one, the square root of 20 times the square root of 15 is A. The answer is A. 20 radical 5. So they had to simplify it. After they multiplied it, they simplified it.
Okay, any questions? Number 3, the cubic root of 16 times the cubic root of 2 is B. The cubic root, 2 cubic roots of 4. The answer is B. It is B. Number 5, the square root of 6 times the square root of 15 is 3, what the square root of 10. Hold on. The square root of 6 times the square root of 15. I wrote down the square root of 10. Let me just double check that really fast. So 6 is 2 times 3, so that stays. So what is that? What's 6 times 15? 90, right? Thank you. 90. And this is 9 times 10. 9's a perfect square, so it comes out as a 3. It's 3 radical 10. My 3, I thought my 3 was a cubic. The answer is 3 radical 10. Sorry. Okay. Number 7, the answer is 64 radical 5. This one is 64 radical 5. And number 9, the answer is 8. Plain old 8. Yes?
Can I have all the answers on?
You got my answer key. I was wondering where that went. I was like, I know I printed a key. Here, I'll give you a blank one.
Why'd you have to say it? That could help.
Because she's honest. She's not going to have the answer key when she takes the SOL, but. I was like, because I had the other answer key, and yesterday I was looking for this, and I was like, I can't find the answer key. I knew I had printed it. I was like, so I had to rework on hopefully my answers. And this is virtual Virginia, so sometimes they have some mistakes, just like me. They make mistakes. All right, so you guys, those 2 worksheets, do the evens and do the evens on the add, subtract, and the multiply. Here's the quiz. This is the quiz. This is the quiz that was on quizzes in the program. And it had a code. And some of you went in and did it. And some of you did not in time. You don't get to it by the time it expires. It does not let you in. It sends me an email that you're trying to get in. So I sent a digital copy of that to you. I'll show you guys. In your Canvas account, I can go to my sent, no, my inbox. Sorry, but there it is. Paper copy, sent right there. So, okay, so there you go. It's there. Okay? And look, I've changed the due date on these 2 things. This quiz, you can start working on it. You've got, let me give you guys the paper copy. But you've also got a digital copy in your email. This is the paper copy. You can go ahead and start working it. If you already did it before, just do it again. Okay? I'll check. If you got 100, don't worry about it. Okay, I think that's all. If they don't make enough copies. Here we go. Yeah, I got copies. Okay, who did I miss here? This is what I sent you in your email. Okay. Okay. If you got the key, tell me so I can take it. Now, your whiteboards and your markers go in the purple bin. In purple.
Whiteboards and markers should be on your phones in the purple bin. Okay? Add and subtract radicals. Add and subtract. Key. Add and subtract. All right, I'm ending the meeting for those that are on the meeting.